Ubisoft's new pirate game, Skull and Bones, kind of sucked. Came out like a year ago and it's still really bad. Compared to what they made 12 years ago, it's actually more of a disaster than bad. It's really embarrassing. So now that a multi-billion-dollar AAA game dev company couldn't make a good pirate game, I think I'm just gonna have to do it myself. Probably the most important thing about the pirate game would be its gameplay loop, have it be interesting. If I were a normal dev, I would probably start doing that, but that's for normies. So I started making the ocean instead, and you know, it's just some water. How hard can it be? Like, it can't be that bad. Okay, so apparently oceans are really hard to make and kind of painful. So there's a few different methods I can use to make the ocean. Number one, Gerstner waves. They're kind of painful, and I don't know how to do that. Number two, a fast Fourier transform, which is what every other major game uses except Skull and Bones. And number three, scrolling textures, which is kind of ass, and I'm just not gonna do it. Problem with the Fourier transform is that it's, number one, really hard to implement because you just make a lot of waves and combine them, and it looks really good. That's why Sea of Thieves World looks so good, but I'm kind of dumb. I don't know how to do that, so I think I'm just gonna do Gerstner waves instead, because they're probably easier. Yeah, so turns out Gerstner waves aren't easy at all. They're really hard and painful, and I'm not this smart. So there's this cool thing that's called, and that's what we're going to do. So the problem with Gerstner waves is that I have to make a shader where they look like waves on the mesh, but then there's no buoyancy, so you just kind of fall through the thing. Obviously that doesn't work, so what am I gonna do now? The smart people that are watching this video will probably get this instantly. Let's just make two Gerstner wave calculations. One on the CPU, one on the GPU, so you don't have to do an asynchronous readback from the GPU. For the people that don't know what an async readback from the GPU is, I can tell you that I don't know that either, so I guess we'll never know. So now that the Gerstner waves are working correctly, we can kind of see that it looks kind of a lot more like an ocean. Except for the fact that it kind of doesn't look like an ocean at all. It looks just like some waves on a flat mesh with no colors, and it kind of looks like ass. So that's a good way to segue into the next segment of the video, which is called... If you've ever looked at an ocean in like movies, games, whatever, you kind of see that they're not gray, and they have sparkles, foam, and these cool ripples. The color part is probably the easiest. We just apply some color and now it looks like it has color. The next part on the list is doing the ripples, and the people that are watching the video and thinking with their brain and not their ass like me thought maybe if we just take a lot of Gerstner waves that we used to make the other waves, we can use them as ripples. So to answer that question, it's kind of, yeah, we could do that, but then we would also have to render the game at like 3 FPS. So there's that, and that kind of doesn't work. So we're gonna have to find another solution. Now, lucky for us, there are actual smart people in the world that have figured out how to solve this problem already. Like using an FFT flipbook texture to simulate the fast Fourier transform. This means that we can overlay the displacement of these textures on top of the Gerstner wave textures and then have it look a lot more real while also having buoyancy. Now that we have done this, we can see that the ocean looks a lot more like an ocean instead of this gray outline of an ocean. Now, let's use our brains for a moment, and then we can think that because the big problem with the Gerstner waves is that we don't get accurate height data from them, with this flipbook texture we get really accurate height data because it's a height map. Now, for the clever people watching this video that are dumb like me, they know that with an accurate height map of the waves, what we can do is use that height data to lerp between two colors. Now, for the dumb people watching this video, lerp kind of just means to smoothly mix two things based on a value. The value that we are using is the height data from the flipbook texture, and we're going to use that to tell that the higher parts of the wave are going to have a lighter color than the bottom parts of the wave. This makes it look a lot more realistic. Now we can also use this to have a much more performant foam simulation than if we had used something else like a Jacobian transform that takes a lot more resources to do. And also that calculation is really hard and I don't know how to do that. Right now our ocean doesn't have any reflections, and that's kind of bad because oceans kind of do have reflections. Lucky for us, a few years ago Unity released a demo on their GitHub which has an ocean with real-time reflections. So we're just gonna borrow them and implement them into our game so we don't have to spend as much time working on it. Now, so those reflections, they're kind of ass and take 100 FPS or so. So I'm just making my own. Yeah, this is gonna go great. Right, so now the ocean is pretty much finished. There's not really much more to do. I could add some particle simulations on top of the foam, but that's a lot of work, and it's like, who really cares? Yeah, so I think this is it. Hope you liked the video. I'm gonna try and make more. I don't know if I will do that though. It depends on how much people like the game and stuff. It has a Steam page. It's going to be in the description, which says now or bad luck forever. So yeah, that's it. Bye guys.